Good afternoon.
Good afternoon.
Forget to put your name in the chat. A practice sheet. Yeah, it's really called a VSEPR lab, but it's a practice sheet. Okay, so we're going to go to it, and if you download it, you'll be able to refer back to it. But here's some, the same rules and some examples. But this right here is your most important part right here. Okay. We're going to do the electron group geometry, some molecular shape. We're going to learn about it from this table right here. So make sure you have it handy, take a picture of it, whatever, so we can refer back to it. Okay. All right. That's where we're going to stop with this one. So let's start the very beginning. All right. So for this one, we're going to have to do, I am not going to be able to write down the crude sketch like it says on there. There's no way, I mean, I'm going to write it outside and then erase it, and you guys just copy it. All right, so the first one that we have, and this is an example, is carbon tetrachloride. And the calculations are right here. So you got 1 carbon at 4 plus 4 chlorines at 7 gives you a total of 32. And then you used 4 bonds at 2 electrons each, or you can just say 8 here if you want. It gives you 24. Okay, so now you know that you need to put your, that's the crude sketch that you're going to make. So you're going to put your carbon in the middle, you're going to put your chlorines and your bonds. Once you do that, then you're going to do the subtraction, right? Once you do the subtraction, then you see how many you have left, and then you create the actual Lewis structure, which there are 24. So the main thing that we want to make sure is that we have enough, and that we watched, also remember the octet that we want. So carbon right here, as you can see, has 4 bonds around it, so it has 8 electrons. That's fine. And each chlorine also has 8 if you count the bond. Sorry, that bond, like that. Okay, so that's okay. So that is a perfect structure. Now, to analyze it, this is what we do. We look at it and we say, okay, so how many things, and by things we mean areas of electron density. Oops, sorry. How many things are around the central atom? Okay, so we determine the general formula for this one to be AB4. AB4 meaning an atom that is central with 4 bonds. There's the B for bonds or bonded atoms, whichever one you want to call it. So there are 4 electron groups. And based on the table that we had up there, when you have 4 electron groups and 0 of them are lone pairs, then you've got what is known as a tetrahedral shape on both cases. All right, so if you have, let me go back to it so we can refer to it again. All right, let me go back. Okay. Right here. Okay, so this table, see how it tells me I have 4 bonded atoms, 4 electron groups, and all 4 are bonded atoms. So that tells me that the electron group geometry, and they're different. Sometimes they're different, sometimes they're not, is tetrahedral. And the molecular shape is also tetrahedral with a 109.5 angle. And a general formula of AB4. Okay, so there you go. So that's where all of this is coming from. All right, so let's go back. So this is why it's so important to know how to make a Lewis structure, because all of that comes from here. All right, now the next question that we have, so we had our general formula, which is an atom with 4 bonds. Electron groups, there are 4. Electron group geometry would be tetrahedral. Bonded atoms, there's still 4. Molecular shape is tetrahedral. We have no resonance structures because we have no double bonds. Now, the polarity is another thing that comes in here. If there are no lone pairs, as in the number of electron groups is equal to the number of bonded atoms, then the molecule is nonpolar. And from there, we will do that later. We can tell what kind of intermolecular forces we have, which we will do that later. All right, so now let's do the next one. All right, so we need to do the math. Let's put that math on here. Let's see, we're going to just type in. Okay, so it's 1 times 3, right? Because that's boron, plus we have 3 times 7, because that's fluorine, right? And that gives us a total of, let's see, 10 and 1 is, oh, sorry, not 10. What am I saying? 21 and 3 is 24, right? All right, so there you go. Now, you make your crude sketch, and that's what I'm going to have to actually write myself, okay? All right, so bonded atom is in the middle, boron, and then you got 3 fluorines, fluorine, fluorine, fluorine. Now from that, we got 24. Oops, sorry, that's not what I need to do that. Okay, so I'm going to release that one and erase this part because I didn't want to do it this way. I want this to be permanent, but not the other part. The other part's okay to not be permanent. Okay, so like I said, from there, we know that 24, we can subtract it from 3, right? 3 times 2, which is 6, which gives us 18, right? 18 electrons. And 18 electrons is pretty good. All right, I'm not going to redraw the Lewis structure. I'm just going to put the valence electrons on the one that I have before because, just to save time. But you guys can go ahead and do what you need to do, okay? All right, so we're going to go. Let me make sure. That's as wide as I'm going to get it, okay? So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we used all 18, right? And remember, boron's an exception, so we're good. This is it. We don't need any more. This is all we needed. Okay, now, of course, as I move up, this thing is going to move up with us, but that's okay. Oops, sorry. Undo that one. Okay. So it's okay because that Lewis structure has to be with us anyway. All right, so looking at it, we can see it's an atom with 3 bonds, right? And I'm just not going to bother putting the lower, this should be lower script like that, right? But I'm not going to bother doing all of them, just this one. All right, and then how many electron groups? Well, electron groups just means things around the central atom. So there's one thing right here. So hold on, let me get my, all right, so one thing right here, one thing right here, and one thing right here. So it's 3 bonds. So 3 things around the central atom. So if you go look at your table, it's going to tell you this is a trigonal planar, which means a flat triangle, okay? So that's what it is, a flat triangle. It's a trigonal planar. All right, once you would go to that, we are going to look at the next part. How many are bonded atoms? See, again, 3, right? So then the trigonal planar might as well just copy paste because it's the same thing right here. All right, so what did we say? We said there is no resonance as long as there are no double bonds. So there are none, right? No resonance structures. And it is nonpolar because we do not have any difference between the number of electron groups right here, right? And the number of, sorry, let me get there we go. The number of electron groups right here and the number of bonded atoms is the same. So there is definitely no polarity, okay? See, no polarity. All right, let's do the next one. And like I said, we're just gonna have to do one at a time. Just erase this one now because I can't have it clearing my area. Okay, now let's do the math for the next one. Okay, the math for the next one is 1 sulfur in group 6, right? Plus, we got 3 oxygens in also group 6, which gives us a total of 24, right? All right, so when we make the Lewis structure, again, we have to remember that the sulfur needs to be in the middle, right? And then you got 3 oxygens going around. Okay, and that gives me the next step. Oops, sorry. When I drag this thing, I forget that I have the pen on me. Okay, so that is 24. And look at it, it looks the same so far, right? Because it is the same structure. If you look at it, it's exactly the same, except we have something else that's going to happen here that's not going to be the same. All right, so 18, right? That's how many we have to put in. All right, so we've got, again, to draw those Lewis structures, we got to put those 18 electrons around it. 2, 4, 6, I'm just going to do them in pairs. 8, 10, 12, 14, 16, and 18. Now, we're good as far as the oxygens, but look at sulfur. Sulfur is not an exception, and sulfur only has 3. So sulfur is going, hey, I am deficient. Give me 1. So what we need to do now is we need to take one of these and move it to the middle as a bond. So we now put a bond on here. Oops, sorry, let me make thin bond. All right, like that. See? And everybody still has 8, right? So there's still 3 things around the central atom, right? That's still the same. All right, so let's bring that structure with us as we fill out the rest. All right, so the type is still an AB3. Why is it an AB3? Because it's still a central atom with 3 bonds. And a double bond is considered a bond, okay? It is a type of bond. Double, triple doesn't count as 3 bonds. And a double doesn't count as 2 bonds. It just counts as a single bond. So this is 3 right here. Again, the same words. So I'm just going to copy it because it's easier than having to type it up. Okay, so that's a trigonal planar. Yep, it's 3 here also because there's nothing else around it. So it's also a trigonal planar. And are there any resonance structures? This time the answer is yes, there are 3. And the reason there are 3, again, is because we could easily, let me get this thing in the middle so we can see it better. Okay, so we could easily take this bond, right, and erase it from there and move it over here. Of course, now we need to adjust the dots, right? And we need to remove some of those on top. But there you go. See? It could do that, or it could also do this. So that's why I said there are 3. bonds, possibilities. So it could go here, and then we could erase this one, or it doesn't matter which one. I just erased one, and then return our dots to this one. See? So there's 3 possibilities. That's why we said there are 3 structures that are possible. Okay. So now let's keep analyzing this. Oops, again. There we go. No, get out of there. Okay, yeah, let's keep analyzing. Okay, so is it polar or non-polar? Based on what we know. Okay. You know how to use the pole features or the features on your thing. Okay, if you think it's polar, put a thumbs up. If you think it's non-polar, put a thumbs down. I don't see anybody answering. Okay, so when you look at okay, so how do we do that? Let's see, we take where you got your participation stuff. You have let's see here. Hold on. Okay, where are we? Reactions. Yeah, there you go. Reactions. Where it says reactions. See how I can do a thumbs up? Oh, wait, okay, there's no thumbs down. Never mind. Never mind. There's only thumbs up. Okay, so let's do it this way. If you think it is polar, put a check. If you think it's non-polar, put a that. Okay, see? See how I did that? All right, so I put that one on because it is definitely non-polar. Why is it non-polar again? Because, and you're going to have to answer, sorry. Now, it's non-polar because it is the same, 3 and 3. Remember, we talked about that, 3 and 3. So 3 electron groups and 3 bonded atoms makes it non-polar. All right, so let's take this thing off, this reaction. Take it off. Yeah. Okay. Okay, see? All right, so next we're going to go to the next compound that we have, and is CO2. Okay, so let's do the math for it. Oh, let me erase this one first because it's kind of in the way. Okay, there we go. All right, so we have 1 carbon in group 4, right? Plus we have 2 oxygens. Oops, no, 2 oxygens in group 6. That gives us a total of 12 plus 4 equals 16, right? Right, so let's do the crude sketch. Our crude sketch would look like this. You would have a carbon in the middle, right? And you have oxygen and oxygen. And I know that's not the prettiest thing, but that's all right. All right, so next, what we need to do is we take off those ones that we used. Come on, you. Oops, nope, not there. Here. Okay, so we take 16 minus, well, we had 2 bonds, right? And we used 2 electrons apiece per bond. So that gives us a total of 12 left, right? And 12 is as many as we can use. So let's put them on there. And always start with the non-central atom first. Okay, so that's 6, 8, 10, and 12. And we have run out. That's all we had left. So now carbon's going, hey, I'm not an exception, and I have a deficit. So again, we need to remove one of these pairs and bring it to the middle as a bond, right? Right here. And I'm just making a deeper bond. It's fine. It doesn't matter. And we'll take another one of these pairs because we're still not happy. Carbon only has 3 now. 3 pairs, I mean. I'm going to call it pairs. And then we need to move it to the center. And there you go. Now carbon's happy, oxygen's still happy, everybody's happy. All right. And like I told you, if you ever want to make sure that you have a correct structure, try to take this number and see if that's the number that you actually use. Look, that's 2, 4, 6, 8, 10, 12, 14, 16. See, that's good. That's all of them. All right, so now let's go to the next part. Okay, so what is our question? Now it's a little different, isn't it? This is totally different from what we had before. All right, so this one, the Lewis structure is up there, so it's coming with us as we go down. So let's look at it. All right. Well, isn't it a central atom? Yes, there is a central atom, so it's A. And how many bonds do we have? And remember, double bonds are just a bond. So 2, right? So AB2. Now, how many electron groups? Well, group-wise, we have 2, right? Group-wise, we only have 2 because each one of the double bonds counts as a group. Okay, so the answer is 2 right here. Now, since we do not know what this one is, let's go look. Let's go look at our chart. Okay, there it is. All right. There it is. Look, number of electron groups, 2. It is called linear. Okay, and it's an AB2. So yeah, and by the way, the angle, which is not on here, it's 180. It's not on there, but I'll put it on there for you. Okay. Okay, and there you go. That's it, 180. Okay. All right, so let's go back down and see where we were. All right, so we were doing CO2. All right here. Okay, so electron group geometry, linear. We just found out, right? Oops, linear. Okay, no, there we go, linear. All right, now I'm going to copy it because I already know that this is going to be the same for the next one. Why do I know? Because there is no difference between the amount of bonded atoms and the amount of things around it, right? So linear. Oops, nope, I copied you. Why do you put that on there? Control C, Control V. Thank you. Okay, so any resonance. We do have double bonds, but there are 2 double bonds. So if one moved to where the other one is, would you even know? No. So there are none. All right. Now, again, here's the question. And I want you to use your reactions. So just go to reactions and say if it is, okay, so I'm going to say it's polar. And you say yes or no by agreeing with either a green check, which is for yes, and an X, a red X, if it's a no. Okay. So which one? Come on, do the reaction. I want to see it. At least one of you. Come on. I don't see a single one of you participating. Come on. I know you can. It's not that hard. Just go to where it says reactions on the very bottom of your screen and select the one I said. So the answer, see reactions. I'm just going to do an applaud just so that you see. See? That's not the answer, obviously. But I want you to do the right answer. So if it's a polar, then you need to put a check. If it's a nonpolar, then you need to put an X. No, nobody. Okay. Here we go. Ah, there we go.
I pressed the arrow thing.
Okay, all right. So you got you think it's polar. Okay. All right. What were the criteria to be non-polar or polar? Okay, so to be polar, this number, which I'm going to highlight right now, and this number have to be different. And they're not. So that means this is a what? Non-polar, right? Non-polar because
You said wait.
right.
So you said the numbers for it to be non-polar, if the numbers are different, then it's not polar?
No, they have to be the same for it to be non-polar, and different.
But if they're
polar.
different,
Right.
okay.
Correct. So in other words, you will have something else other than a bond around the central atom. And right now, there's nothing but bonds. Okay. You understand that? Yeah.
Yes.
Okay. All right, good. All right, so see how all of them have been non-polar so far? Because they're all the same. Okay. Now let's look at the next one. You can remove your little check mark. Just go back to it and click it again. Okay, sorry. All right, now the next one is ClO2. Let's clear this baby up because we do not want that one again. All right, so now for this particular one, we're going to have okay, so ClO2 negative. Okay, notice it's negative. All right, so let's do the math. We got 1 chlorine, right, times 7 plus we have 2 oxygens times 6 plus, yes, there is one more from the charge, right? Remember that charge gives you 1 extra electron. So that's a total of, sorry, I'm trying to write down the name of the person that just came in. All right, there we go. That's a total of 12 plus 8 is 20, right? Is that correct? Did I do that math correctly? Oops, that's not plus, that's equal to 20. Okay, there we go. All right, so when we do our structure, right, we need to do the way that we've been doing it, right? So it's chlorine in the middle, and then oxygen, oxygen, right? All right, so now we have more math to do. So out of those 20, how many did we use? We used 20 minus, we have 2 bonds, and each one counts for 2 electrons. Therefore, we have 16 electrons to go, yes? All right, so 16 electrons to place. This is kind of cool. We got a lot. Let's do them. Okay, so always do the outer ones first. 1, 2, 3, 4, 5, 6. So 6. And I'm just going to start counting. 8, 10, 12. Sorry, 12, 14, and 16. I got distracted because somebody just came in and I needed to let them in. Sorry. Man, my pen just flew across town. All right, so, okay. So as you can see, that is, sorry, I'm gonna grab my pen back up because, like I said, it flew across town. So, okay, so, all right. So this is a little different from what we've seen so far. Oh, and the other thing, since it is an ion, don't forget that you need to do the bracket and charge, right? All right, so there's your Lewis structure. Okay, so let's keep going with this and let's see what we got. Okay, so now the next thing, that is our Lewis structure, that would be there, right? So what is our formula? Look at it. Now we have a central atom with 2 bonds. Yes, 2 bonds. You agree there's 1, 2 bonds. But there's also two other things around it. Two electron pairs. So that is how you write the general formula. And remember, these have to be lowered down here. Oops, come here you. Okay, so this one and like that, right? So because it's two electron pairs, two bonds. So how many things are around the central atom? This time there's four, right? Because there's I'm going to point to them all. Okay, there's 1, 2, 3, 4. See? All right, so this officially is a tetrahedral. Oops, I can't do that with this pointing at me. It's a tetrahedral, which I'm going to copy. All right, so that is right here. Not again. See, I have to do Control C, and it didn't work for some reason. Control C. Maybe I didn't hit it hard enough. There we go. All right. Now, how many of those are bonded atoms? Only 2. Ah, here's a different story. Now we need to go check what this shape would be. It's not linear. What is it called? Let's go look. All right. So based on what we know, it's an AB2E2. So we got 4 and 2, right? 4 and 2. So we're looking for our table. And we got 4 and 2. So 4 are electron groups, 2 are bonded atoms, tetrahedral. It is called bent. You see that? There it is, bent. And there's your angle, and there's your general formula. So this looks like the right one. So we're just going to say it's bent. Right? Let's go back up to down to where we were. Okay, so the answer to this one is bent. All right, now, do we have any resonance? No, we do not, because we do not have double bonds. Now, here's the question. Again, I'm posing this one to you. Is it polar or non-polar? If it's polar, put a check. If it's non-polar, put a cross, the X with the red circle. So try clicking it and see if you can. Okay. Best way to learn is to actually participate in class, and there's a reason that you want to do that. All right, so nobody's participating, but all right. So
I just don't really understand it. I'm gonna be honest with you.
Okay, so remember the two numbers that I told you that are different, right? Or the same. See, they're highlighted. Is 4 and 2 the same or different?
They are different, so they're polar, right?
Correct. See, you do understand it.
Okay.
See, you do understand it. You do understand.
So if the electron group and the number of atoms are different, is polar the same, non-polar?
Correct.
Okay.
Those two that I highlighted, that's why I highlighted them. I left them non-polar. That is weird. Non-polar. I don't know where. Sorry. I was just looking at that. It's like, what? Okay, non-polar. No, polar down there. Okay, so that's the reason why. The reason is because these two numbers are not the same. So you have an electron group that is one number, and you have a bonded atom number that's different. See how you got this bond. Oops, hold on. I cannot do that one like that. I have to do this one with my circles. Let's get a different color so it doesn't look the same. Let's do green. All right, so right here, you got 1 and you got 2 bonds. So that's what this is, right? That's this 2. And then you've got 1, 2 more things around it, so that's why it's 4, you see? And that's what makes the difference, because you have lone pairs. If you didn't have lone pairs, that would not be polar at all. But since you do have lone pairs, it is polar. And also, you notice that the shape from the electron group geometry, this shape and this shape are different. That is also another clue. So there are 3 ways of knowing whether it's polar. Number one, those two numbers that I showed you, the electron groups and the number of bonded atoms, right? Number two, does it have lone pairs around the central atom? That's the other one. And number three, your general formula, if it has an E right here, this general formula that I had highlighted, if it has an E, then the answer is polar. Okay, so there's a lot of ways of telling. And the reason that is because it's not symmetrical. And we'll look at that later, but right now we're just looking at this part. And when we're saying they're non-polar or they're polar or whatever, it, you know, it means nothing right now to you, maybe, but it will soon, because the next class we will look at intermolecular forces, and all that stuff is very important for any kind of interaction between atoms. Okay, so we have another page. Oops, here I go again with my thing. Okay. Okay, there we go. All right, so here we go. Now, for this one, I would like you guys to kind of try to do it yourself as we're looking at it. Okay, so you always do the calculations first, right? Okay, so this is water. So you know that there are two hydrogens, right? And each one is a 1. Plus, there's 1 oxygen, and that's a 6. That's a total of 8, right? Okay, so when we do that, now we need to make our crude sketch, which means that the oxygen's in the middle, because hydrogen can never be in the middle. Remember, we talked about that, because it only makes 1 bond. And you cannot have something in the middle of something if it only makes 1 bond. There. So that's our crude sketch. Now, let's keep the calculations going, because you have to do one more calculation after you figure out how many bonds you got. Okay, so once you do that, you enter that and you say 8 minus. You have 2 bonds, right? And each one of those is 2 electrons. So that gives you a total of 4 left. All right. The 4 electrons we're going to place them around the outer atoms first, but the outer atoms happen to be hydrogen, so there are no lone pairs for hydrogen at all. So they only have 2 for oxygen, and that's it. That's the whole sketch. All right, so once we do that, let's go back down and look at the general formula. What do you think this general formula is? All right, so is there a central atom? Yes. So A, right? That's what that means. Are there any bonds? Yes. How many? 2. Are there any electron pairs? Yes. How many? 2. See? So the electron groups, there's actually 4. The electron group geometry would be tetrahedral, right? Number of bonded atoms, we have only 2. Molecular shape is bent. So do we have any resonance? The answer is no, because we do not have double bonds, so there can be no resonance with double bonds. Is it polar or non-polar? And here's where the question is, the really good question. It is polar, because again, we have 3 reasons, 3 ways of telling, and they're all right there. You have, the main thing is when you look at your Lewis structure, does it have lone pairs? Yes, it does. There you go. It's polar. That's all you need to know. Lone pairs in the central atom. I mean, they can have lone pairs all around it. As long as the central atom doesn't have any, it's non-polar. But if it does have 1, then it is polar. Oops, sorry. That thing just came up. All right. So now let's go to the next one. And we're going to do a few. Okay, SO4 -2. So this is another one that is one of those ion ones that you need to remember, that -2 has to be counted in the totals. All right, so we got 1 sulfur, right? Times 6 plus we have 4 oxygens times 6, plus we have the charge of 2. So this is a total of how many? Let's see, 32. Am I right? Yeah, okay. So that's 32. All right, now do your sketch. Let me, let's see, let's do it in, let's do not do green anymore. Let's do blue this time, just to have something different. Okay, so S, ooh, okay, O, 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 right? O, O, O. So there you go. Now you need to do your math again. All right, we have 32. From these, we need to subtract 4 bonds. Each of them is 2 electrons, so 8, right? So 32 minus 8 is, hold on. It is definitely not 18, it's 24. Yeah. All right. 32 minus 8. Yeah, it is. All right. So there you go. So now we know how many electrons we have available to place around the central atom. And for this one, we have 24. So 1, 2, 3, 4, 5, 6, 8, 10, 12. I know I'm doing them all random. 14, 16, 18, 20, 22, and 2 more is 24. So that's it. We ran out. And everybody looks happy to me because sulfur has 4 bonds, which means it has 8 electrons around it. And oxygen has its 6 electrons plus the bond makes 8. So everybody's happy. The only thing is we need to indicate the charge, right? That's the one thing we haven't done. And just put the -2 on there. And there you go. There's your Lewis structure. All right. So we're going back to the beginning that we had before, pretty much. All right, so what do we see here? Okay, let's look. All right, we have an AB2, no, not 2, AB4, right? AB4, because we have 4 things around the central atom, they're all bonds. So 4 electron groups. This is tetrahedral, I'll just copy this. Yep, and this is still 4, right? Because there's nothing else around the central atom except bonds. So the molecular shape, again, is tetrahedral. There are no resonance because there's no double bonds to move around. Oops, sorry. Why did I put tetrahedral on there? I mean, none. And is it polar or non-polar? This time, those 2 numbers are the same. There are no lone pairs. So, none. I mean, non-polar. Non-polar. There we go. Where's my L? Polar. There we go. See? So you're getting the gist of it pretty much? How to do these? Yeah? You want me to do more? No? Okay. All right, well, that's how you do these. This is the way to do all of your Lewis structures. Now, when you are looking at any of these, now there's one in here that I haven't covered, and I'm going to go to the very bottom, and this is our last one. This one right here, this one, CL3. All right, there's one more criterion to whether it's polar or non-polar. And this is going to blow your mind because of the way that we've been doing it. It's not at all that. This time is different. This time we are needing to do our math. Well, same thing. The math is the same. So let's do the math first. Okay, so we got 1 carbon times 4 plus we have 1 hydrogen, right, times 1 plus we have 3 chlorines times 7. That's a total of, oops, That's supposed to be 3. Okay, that's a total of, let's see, that's 5, that's 21 plus 5 is 26, no? Oops, that's supposed to be equal to 26. All right. So same thing we've been doing. Just let's just do that. Okay, so carbon in the middle always, because remember, hydrogen can't be in the middle. So all your chlorines, let's put them first. Doesn't matter where you put them. I'm just doing it because I want to. And then put the hydrogen on the bottom. Okay, so there's your bond. Oops, I know that's hard to see, but that's your hydrogen. Okay, so now we have 4 bonds, right? So let's go back to that. We have 26. I think that's right. Somebody do the math for me and tell me if I messed it up. Okay, so we have 4 bonds at 2 each, right? That gives me a total of 16. See, that's something wrong on this one. Okay, 21 plus 1 is 22, 26. No, that's right. 26 minus 8 is 16. No, it should be 18. That's what it is. That's me. That's me in the math. Okay, it's 18. That's sort of like, that can't be right. Okay, so now next, we are going to place those 18 electrons around. Always try to do the outer atoms first, like I said, because it works better, especially when you run out. If you run out at all, then you can always fix that later, and you'll know that you ran out. Okay, that's my 16, right? I mean 18, right? Okay, hydrogen doesn't need any. Carbon's happy, so that's it. See, when you do the Lewis structure thing, right? It's right there. The general formula is going to be an AB4. So that is like, wait a minute, there's no E. Electron groups is still 4. Electron geometry is tetrahedral. Number of bonded atoms still 4. Molecular shape is still tetrahedral. But there's something that's different. And that's what you have to remember. When there's one other difference. Okay, so there are no resonance structures. And is it polar or non-polar? Okay, so far we learned that if the 2 numbers are the same, oh, that's a T. If the 2 numbers are the same, right, then it needs to be non-polar. But the one thing we didn't see is one that was different. One is not like the others. So look at this one last part right here where it actually describes what a polarity is. Okay, so hold on, okay, right there. All right, let's read this one little piece right here. It says, and I'm going to highlight it. Okay, so it says, a molecule. Okay, so another way to state this is if the electron group and molecular shapes are the same and the atoms attached to the central atom are identical, then the molecule is nonpolar. But in this case, this guy right here is not the same. This one, he is different. So therefore, this is a polar molecule. I know, I told you it was going to just, but that's the last criterion that we hadn't had so far. But in this case, we did have it. And we are now going to go back down here and say polar. On this one, where do you go? There you are, the last thing we were doing. All right. And yes, it is polar. And the only reason it's polar is because of that hydrogen that is different from all the others. So that creates an imbalance of charges and it makes it polar. Okay. All right. That's it. Next time we will look at intermolecular forces and we will use this same thing. I will have it probably complete by the time you get in. and at least part of it, not all the Lewis structures, but I will have all the answers pulled in already, and then you will have to look at it and analyze the few things we're going to learn. So it's not a big deal. You'll see. It's that this is probably one of the easiest parts, is how determining the intermolecular forces within a molecule. All right. You guys have a great weekend.